Yo, what's up, everyone? So it's week 6, and hopefully you remember that this week we have a test. And even though we have a test, the structures of class are going to be the exact same. We're going to have 2 problem sets. This is the first one, and then it's a review set. And then the second problem set that I give you on Wednesday is going to be a practice test. Okay, so I gave you review set number 1 last week for Thursday. I'm giving you a review set 2 for this lesson, and then you have a practice test, which is going to be problem set number 2. So those are your 3 main resources for practicing for this test. And then on Thursday, I will release the test, and I'm going to grade this one. It's not going to be self-graded, so all you have to do is put it in your drive, okay? All of it's mandatory, so just make sure you're still doing all the practice. And even though we're in week 6, I don't think we've learned 5 weeks of material yet. We have learned some hard things, but as I look back, we took a lot of review days because this stuff was tricky. So I don't want you to be too worried about this test, okay? So make sure you do every review set, but I'm not going to try to trick you on the test, I promise. Okay, the test will be going crazy outside. The test is going to be identical to the practice test, like in form, not in the actual numbers. But yeah. Okay, so we're going to talk about this test, and this test is pretty much just graphing linear and piecewise, right? So we know we have piecewise equations, we have linear equations, and we have to be able to not only identify the equations for them, but sometimes graph them as well. Okay, so we have to go both ways with the graphing component, but the other big part of this unit is talking about functions and the domain and the range, okay? So if we're looking at a graph, like the one we have on the right here, the first thing that we're going to do before we do any math is just confirm that it is a function, that we can write a proper equation for the graph, and that what's happening in the graph is legal, right? So we know that some things aren't allowed in a graph, and I like to consider them like illegal things in a graph. And if anything illegal is happening in the graph, then it's not a function, okay? And remember that the big thing, or the big way to figure out if something is a function or not is the vertical line test. Because what we know is that x can't equal, we know that x can't equal 2 things at the same time. That's like the big thing about a function. So we always can draw vertical lines, and if you draw a vertical line that intersects your line twice, that means that x is going to equal 2 things at the same time. So first, let me do an easier one. Here, this is a vertical line, kinda. I sucked at the end part of it, but x hits it at 2 points. So we know that that's not allowed. X can only equal one of these points at the same time. So whenever you look at a graph, to test if it's a function, you have to see, does it ever equal 2 points? So it fails here. But there is a trickier fail that I wanted to talk about, and that's the 2 closed circles, okay? Remember that closed is equal, and that means that we are this point. So if both of your circles at a point are closed, that means that x equals this and this, okay? You can't equal 2 things at the same time. So 2 closed circles is also going to fail the vertical line test. And just to be clear, like let's just imagine this was an open circle, like one of these. This would be valid, okay? Because it would only be equal to this one, not equal to this one. And even further than that, if both circles are open, it's also okay. Because x is allowed to not equal something, but it just can't equal 2 things. So the only thing that's not allowed at an endpoint situation like this is 2 closed circles. Okay, so I'm going to write that and then say it out loud again. Okay, so what I wrote is no, because it fails the vertical line test with 2 overlapping lines, right? These lines overlap each other, and we have 2 closed circles, so it fails twice. And this question is short, we're already done with it, and that's because if you don't have a function, you don't do math, okay? This is bad, so we don't do any math with it. So on the test, if you ever had a non-function, maybe I'd give you 2 questions like this, 1 yes, 1 no, but we can't proceed like we're going to do with example 2 without it being a function. So hopefully that makes sense. And now we'll do number 2. And all of these I want you to put the ends on if it asks you to. And first it asks us if it is a function. So the first thing is to notice that it's not perfect looking. It is a little funky because there's a gap, right? I know that's not that pretty, but there's no line from 2 to 4. Okay, so nothing's happening on our graph here. So if you're trying to figure out if it's a function or not, this might scare you because it's not continuous. It doesn't go here to here, then to here. But the good news is your function doesn't need to be continuous. Okay, sometimes in the real world with a word problem, x will skip values. Okay, x doesn't have to equal every point. There can be gaps as long as it passes the vertical line test. So here, look. On this portion, there's no part where our lines overlap. And then here there's a gap, which is fine, but this is a singular line as well. So yes, because it passes the vertical line test. But what's really important here is even though there's a gap, it's still valid. Okay, so we're going to do domain and range now. And this is an example of something that I think I missed before. Not like it's new, but we're trying to figure out what's possible on my graph. So we know that domain is my x values. So if I'm trying to find the domain, all I have to do is go from the left side of my graph to the right side of my graph and figure out what values are possible and what values are not possible. If we have this arrow, that means it will go to negative infinity. This line will continue forever. So negative infinity is the start of my interval because we have that arrow. And x is going to be able to equal every single value until we get to 2, right? All of these are valid. We're just looking for what x values are possible. After we get to 2, we don't equal 2 because we have an open circle, and then we have a gap before we get to 4, which we do equal because it's a closed circle. From 4 forever, it continues. Okay, so if you have end arrows, that actually always is going to signal that you go from negative infinity to infinity for a domain. And the hardest part now is the open versus closed circles. The open versus closed brackets, right? The soft versus hard brackets. So we know we have negative infinity, comma 2, because we write it with this thing. And we have 4 comma infinity. We just have to figure out, is it going to be a soft bracket or a hard bracket? And we know the soft bracket does not equal. Soft bracket is the same thing as open circle, and hard bracket is the same thing as closed circle. So here, remember that you can never actually get to negative infinity. So think that anytime you have a negative infinity or infinity sign, it's going to be a open circle. But we have to figure out, is 2 open or closed? So because it's open, we don't equal that point, so we use a soft bracket. Okay, so this part of my interval is saying that our graph goes from negative infinity to 2, but we never reach negative infinity and we never reach 2. We get as close as we possibly can, but we never get there. U stands for union because we have 2 parts of this. There was a break, but after the break, we start at 4 with a closed circle. So the closed circle is when you're going to have the hard bracket because we actually equal 4. We don't equal negative infinity or infinity. We never actually get there. And we don't equal 2 because it's an open circle. But we do equal 4, so that's our hard bracket. So hopefully that makes sense to everyone. And if it is a little tricky, let's do the range so that we can see the comparison. So domain is left to right, and range is down to up. Okay? So we have to figure out what is the lowest value. And again here, if we have this arrow going down and to the left, that means my graph is going to go down forever. Okay, so my graph is going from negative infinity all the way until it stops. Okay? And here, you know, we see it stops, but remember that y values are continuing until we get to this particular point, which is y equals 2, okay? So it's all about the difference between x and y. In this instance, we go from negative infinity to 2, but then there's no values from here to here, right? So negative infinity to 2, there's a break from 2 all the way until we get to 5. I think this circle thing looks stupid. I don't know if that helped explain anything. Probably better without it. But we're trying to figure out down to up. So down to 2, 2 break to 5, nothing here. And then 5, are we going up? And that is what I was alluding to as the new stuff. This equation is just a horizontal line going this way, right? So my graph isn't going to continue going up. We're never going to be 6 or 7 or 8 or 9 or 10 or 11 or infinity. We're going to be nothing above 5. So let's write that down. We'll start with the easiest part. We go from negative infinity to 2, and it does equal 2. Okay, if you don't see an open or closed circle, it's implied, because at this point, negative 4, 2, it's definitely equal to them. So here, it goes from negative infinity to 2 again, but now in the y. But how are we going to talk about this 5? After we get to 2, y doesn't equal anything else above it except for 5. It never equals 3, 4, or sorry, this is 6, lol. Damn. Conceptually, it all hopefully makes sense though. Man, damn. But yeah, 6 is this y value. So we're never equal to 3 or 4 or 5, but we are equal to 6, but we're never equal to 7, 8, 9, or 10. So the way that we can write that is just put 6 in a closed circle bracket or a hard bracket instead. Y equals everything from negative infinity to 2 and 6, but nothing else. So this is valid. You don't actually need a lower and an upper number. It will equal just this particular number. So that is the range of the function. And we're crushing it on time. And we're gonna, and all of this is review, so hopefully you guys feel good. But now we want to write the piecewise for this function. And remember that the hardest part about this is going to be the y-intercepts. But we have 3 different parts of my graph. We have 1, then we change because we start going down 2. There's a break, but that's not an equation. And then there's a third part here. So we have to write 3 different equations at 3 different intervals. And remember that my personal favorite way to do this is to write in the intervals first and then write in the equations. And that always, remember, connects to our domain. And that's why I kind of like to do that. So my first section is from the very beginning, negative infinity, and stops at negative 4. Okay, so we're reading it from left to right for these intervals, and we have to write it now in interval form with the less than or equal to signs. So remember, this is going to go hand in hand with this. Negative infinity is less than x, which is less than or equal to negative 4. Okay, and remember that if you have a less than sign without the less than or equal to, that's the same thing as a soft bracket and an open circle. Okay, less than or equal to, that's going to say we are equal to that point. So we never reach negative infinity, but we do equal negative 4. Okay, but once we hit negative 4, we're going to change again. So that's the first interval of my graph. And now let's write in the second interval, which goes from negative 4 to 2. It does equal negative 4, but it doesn't equal 2 because of the open circle. So that would be our interval. And then finally, our last section goes from 4 to infinity. Here there's no break in that, so it's just those. And it's a closed circle. So this is going to be a less than or equal to sign. And again, you can check your interval work by comparing it to your domain. Negative infinity to negative 4, but it's equal to that point, all the way to 2. So negative infinity to 2, then a break, and then 4 to infinity. And once you do that, you should feel pretty confident, because the last step is to just write the equations in, which is the beginning of the unit. So we want to write what this equals. And remember, what's hard is well, first let's find the slope. The slope here is 2, because we go to the right one and up 2. But we have to figure out what the y-intercept would be if this line continued. Because remember, we're only graphing a portion of this line. We're only graphing from negative infinity to negative 4. But this line could go forever, and we want to know what the y-intercept is if it does go forever. So let me show you. For this one, I'm going to do a shortcut. We know the slope is 2, so I keep going up 2. So all I'm going to visualize is that if this line continued, it would reach the y-intercept of 10. Okay? So if I was ignoring everything else going on in my graph and was asked to find the equation for this line, the equation would be 2x plus 10. Even though we never reach 10, because we stop at this x equals negative 4. Hopefully that makes sense to people. Whichever part of your graph intersects the y-intercept is going to be the easiest by far, because we know that it's going to be plus 1 because the y-intercept is 1. And once we know that, let's figure out the slope, which is change in x and change in y. It's going down, so it's going to be negative, and it's going down 1 for every change in y of 4. So the slope here is negative 1/4. And I hope we're okay with this, because I've reviewed this a lot, especially last week. We talked so much about this, but it's the hardest stuff, so we keep doing it. But that's why I'm running through the slopes kind of quickly. So 1 over 4, and it's negative, so negative 1/4. And the y-intercept is 1. Finally, we have this third part of it, and it's a horizontal line. And if we have a horizontal line, the equation is going to be something like y equals a number, right? So because this is the number 6, this is just y equals 6. And we don't have to necessarily even worry about what happens to the y-intercept, because it's not changing. It's going to be 6 forever. So that would be that. Okay, so that's a hard question in my opinion, but that's the hardest you could get on the test. And hopefully that makes sense to everyone. But we're going to cover a few more things. Okay, so for number 3, this is going to be really easy. But I want to talk about domain and range, where we just talked about if we have a normal linear equation. And it's really easy. First, both of these are asking if they're functions. And if you just see a line, you don't need to overthink that at all. Okay? Piecewise functions are the only time that could get complicated, because you would get overlapping lines. But if you have a single line on your graph that doesn't go back on itself, like something like that, it's going to always be a function. Okay? All lines are functions, but not all piecewise are functions. For this one, domain and range is complicated but extremely easy every time. Think that this graph has no breaks, okay? It starts at the beginning and it keeps going until the end. So any line is going to have a domain of negative infinity to infinity. Okay? Same thing we can say here, honestly. Because we added those arrows in, it starts at the beginning and it keeps going to the end. So the same thing is happening here. Right? No breaks at all. It's going to go both ways forever. And for the one on the left, we can actually say the same thing. about the range? Ignore that. But this is going to go down forever, and this is going to go up forever. So nothing is stopping this line from just going up and down and left and right forever. And that is actually the case for almost every linear equation you have. Okay, so if you ever see a line with a slope, no slope, slope, anything that's moving, you know what I'm saying? Like that looks stupid, but like any line is going to be a domain and a range of negative infinity to infinity. Okay, because it's going to continue forever, unless it has no slope. And I love this example because hopefully it ties everything in together. But remember that range is talking about up and down. But if we're horizontal, we don't go up and down at all. It does not equal -5. It does not equal 5. What y values does it equal? It only equals -3 forever. Okay, so x can be every single number. X can be -1,000, x can be -5, x can be 10, but y is always going to be -3. So the range is -3. Okay, and we haven't talked about vertical lines yet because they're literally the definition of not a function because every single x value is the same. But those would be flipped in that case. Okay, but vertical lines are less important than horizontal lines. IMO. All right, so I wanted to cover one more question, example problem 4, but I'm running a little low on time because I wanted this video to be 25 minutes and I'm already there. But I'm gonna see if I can do some editing magic to get us through this pretty quickly and understand it. But just know that the difference now, so we start with the equation and we have to move each of these sections, we have 3 sections, onto the graph. Okay? And the key again is going to be to look at your intervals to start. And there is a little difference on this that I wanted to talk about. And I always start with the first interval. Okay, so this represents the first part of my graph. The first part of my graph is 3x plus 9 from -8 to -4. And remember, you don't have to reinvent the wheel at all. All you have to do here is plug in a point into the equation. In fact, let's just plug in -8 and -4, and that's going to tell us what it looks like, right? So you can make a quick table in a lot of these instances, and that's going to help you so much. So let me put this first one in. -8 and -4 help because these are going to be our 2 open circles, right? We know they're both open because we have the less than sign and not the less than or equal to. Okay, so I actually changed it to -6 to -4 because -8 was going to be off the graph, but -6 times 3, -18, plus 9 will give me -9, and then -4, -12, -3. I know I just said numbers out loud, but hopefully you're solid with plugging in. -6 to -9 is the start of my graph, and this is an open circle because it does not equal -6. It equals everything next to it, but it won't reach that point. Then we have -4, which is my next point, comma 3, -3. And you can use the slope, you could just combine the points, but we know that the slope is 3, so you go to the right one up 3, to the right one up 3, and that's going to be the first portion of my piecewise. And what would be potentially new here is if you, or like tricky is if you see those less than signs, that's the open circle. My second part is 1/2 x plus 5/2, and this goes from -2 to 5. And because we have the y-intercept, we can start with that point, 5/2. And 5/2 is just 2.5. And from there, the slope is 1/2. And because it's a half, that means we're just going to go up 1. Okay, so I did that super quick, but what's important here is they're both closed circles because we have those less than or equal to signs. So that's the second part of my graph, and then the third part of my graph is this 5 from 5 to infinity, which is that. So it goes forever. And we did that quickly, I'm really happy, and let's talk about domain and range. And first, domain has been started at -infinity for all of these, but if we look at our graph and look at our intervals, this graph only starts at -6. Okay, so if you see an open or closed circle before the graph ends, no arrow, and no indication that it goes forever, you're not going to go to negative infinity. Okay, so this domain is really hard in my opinion because it's going to have a lot of different things happen. So x goes from -6 to -4. Then it has a break, as indicated here. We have -2, but here we go forever, okay? Again, this is definitely a function. The break doesn't matter. It's just going to complicate this. But we have two open circles. So this domain starts with -6 to -4, not equal to those two. But then it's definitely equal to -2 all the way to infinity. And then finally for range here, there's no arrow on the left side, which makes it harder, but the lowest value is -9. -9 goes all the way to -3 before it stops. And then you would have to make sure you found exactly what this point was. Okay, so we were at 0,5/2. So we moved over 1 this way. So this is -2, comma, 3/2. Okay, so 3/2 is what ends this next gap. We go from here to here with a gap. And then we want to figure out, again, is this going to go forever? And the answer is no, because this is a horizontal line. So it's not going to make it to either infinity in this case, but we have two different intervals, okay? And in that first interval, it was all open circles. And in that second interval, it was closed circles. It definitely equals 3/2, and it definitely equals 5. It equals 5 so much. So those are those domain and ranges. So really excellent job today. We have covered everything now multiple times, and we'll do a practice test on Wednesday. So really proud of you, and yeah.